Hello and welcome to this BG technical presentation. My name is Frank Massey of ADS in Preston. First of all, I'd like to thank Andrew Clarkson for the use of his four-wheel dyno. His business is based in West Thornton near Bolton. The purpose of this presentation is not just to review the BG products, how they affect and improve the performance of diesel engines, but more interestingly to see what exactly those improvements are. We, as users of BG for many years now, have had a lot of success from owners of the vehicle reporting back improvements in drivability experience. We've quite often been asked the question, exactly what improvements are to be gained in terms of economy, delivery of power, etc. So, the purpose of today is to apply each of these products in a methodical and logistical manner whilst monitoring actual power up on Andrew's four-wheel dyno. So it should be very interesting from my point of view to see what the improvements are to be gained. The vehicle we're going to use is this Hyundai Santa Fe 2.2. It's Bosch Common Rail EDC 17 Common Rail diesel. The mileage is just under 60,000, 59,000 and a few hundred miles. The service history and the regime of service care is very important. We're starting now to focus on customer profile. This profile is based upon their service regime and their environmental regime. In other words, how do they drive the car? How do they have the car serviced? This car has had an average service life. It's not been treated before with any of these products. So this is a genuine unknown test. Neither I nor anyone else involved with this project today has any idea of what benefits are going to be gained. This vehicle has been used mainly on the open road, mainly on the motorway, with an average fuel, supermarket fuel and some premium products of fuel used in the vehicle. I'd like first of all to explain each of the products that we're going to use, how those products affect the recovery and improvement to the vehicle operating systems, and in what order in which we are going to apply them, and then we're going to do some dyno runs and have a look at the results. The first of the products we intend to apply, and this is a very obvious first product, is the ISC, Intake System Cleaner. The purpose of this product is to remove the soft carbon-based deposits which occur naturally in a diesel intake system, mainly due to EGR, passage of unburned carbon products from the sump via blow pass by the rings. It's designed to be delivered in an atomised format. The vehicle runs on its natural fuel product, diesel of course. This product is injected as close to the engine intake manifold as possible. We suggest as close to the motorised throttle body and EGR valve as is possible. It will treat obviously the throttle body, the EGR valve, intake swirl flaps, intake manifold, the back of the valves, the cylinders, and of course not forgetting the turbo and equally as important the DPF system on the exit circuit. As I say, this product is designed to recover unburned carbon products from the inlet manifold. The next product is the 109 additive. Now, one of the main contributors of carbon-based deposits and a drop in performance is the deterioration in the compression capability of the diesel engine. Now, I think we'll all appreciate that the critical factor of delivering diesel fuel and burning it efficiently is a very high compression ratio. It's effectively ignited by heat generated under the compression process. This product is designed to remove lacquer-based contaminants that can cause the rings to become sticky and to reduce the efficiency of compression. That product is normally added to the existing oil before an oil and filter change is then applied. So this effectively washes or cleans the engine, sump system, lubrication system, valves, tappets, etc. The 244 product is a direct additive into the fuel tank. It's designed to help the combustion process become more efficient, more effective, and to reduce the amount of free carbon or residual carbon products following combustion. So effectively, it should present the DPF with less carbon to deal with than it would normally have without the product. So that is added directly into the fuel tank. And generally speaking, depending on the ratio of fuel quantity, one tin application per tank of fuel. The final product is the DOC, diesel oil additive. This product is essentially designed to assist the oil's ability in resisting the build-up of acid-based deposits. The classification, if you like, of these agents in oil, for quality oil in diesel oils, low ash oils, is probably around 10 to 14. I believe the ratio in this tin increases that resistance factor to a value of 44. So basically what I'm saying in layman's terms, and I am that person, is that this will improve the oil's ability to resist acid contamination by a factor of 3. In doing so, it holds in suspension the carbon deposits which then would normally have been ingested by the EGR system and the breathing system back into the exhaust, of course the DPF. So a series of additives to be delivered into the vehicle more or less in the order we've just discussed. So what we're going to do is we're going to do a dyno run with no additives whatsoever. There's been no pre-preparation to this vehicle whatever. It's been strapped down to the road. We haven't even done a single dyno run yet, so none of us know what the power figures are going to be. We're then going to do the intake system flush and then progressively add the other products and then monitor the benefits from those products. I did say that briefly we'd take a look at the actual hardware involved. This is a pressurized container supplied with 150 psi from a standard workshop compressor. That's the intake pressure gauge. There is an outlet gauge and control valve, which is the exit control monitoring gauge. We deliver this product, that's the intake system cleaner, at around 6 bars I previously suggested, into a injector, which this is not yet obviously connected to the vehicle. This is the injector system. It has, for want of a better word, a vortex generator. This, if I just spin that around so you can see that, it allows a small amount of air to be drawn through this vortex generator. It's like a helix inside to create turbulence. In the center of that device is the injector. That injector atomizes the intake system flush, and the benefit of that is that by atomizing any liquid product, the ingestion of that product and the delivery of that product is going to be much more efficient than, say, a simple aerosol device. It's also being ingested whilst the engine runs at a slightly higher than normal idle speed. The trigger box is designed to control the delivery of the product intermittently, either by a 12-second cycle time or a 17-second cycle time, the selection of which is made simply by that switch. Off is in the centre, and 17 to the right, and 12 to the left. The benefit of this effectively intermittent injection is it allows the product to be atomized very efficiently whilst the engine's running to enable the dispersion of the product equally into the manifold and all of the essential components. That said, I think our next objective is to conduct an initial dyno run. As I said earlier, this vehicle has not been run before. None of us know what the power consumption of this vehicle, power output of this vehicle is. It may be worth noting that today is extremely hot, and that does affect power output figures. So accepting that we're on a very hot, humid day, without further ado, let's do a dyno run and have a look at the results of that run before we then apply these products in a progressive manner and observe the improvements. During the short break in filming, Andrew has calibrated the rollers and conducted 2 individual power runs. What I'd like to do now is go over those results. These are the primary results from which we're going to compare then the application of the different products. At the moment, as I say, repeat, no products yet have been added to this vehicle. These are the results that Andrew has achieved on the first run. A couple of interesting points here I'd like to highlight. Peak horsepower was achieved at 4,133 RPM with slightly under 220 horsepower flywheel horsepower returned. The transmissional losses, in other words horsepower at the road wheels, came out at just over 180, maybe 182, 183. So net difference of around 40 horsepower, 36, 37 horsepower of transmissional losses. The net torque was slightly over 330 foot-pounds of torque delivered at around 3,800, 4,000 RPM. The first of the 2 products we're going to add now to the vehicle is the ISC, the intake system cleaner. We're also going to add the BG109. This is the additive which is introduced into the existing oil. This is to cleanse the vital mechanical components, especially the piston rings, tappets, valve gear, etc. This will help restore compression and improve the combustion, and from that improvement, hopefully, more power, better economy. The first of the products I'm going to introduce is the BG109 oil additive. What I'd like to do, whilst I'm just adding this particular product, is perhaps, if I may, give a little advice as to what oil really has to contend with. First of all, we do not support, as a company, that's us at ADS and Preston, long life servicing. I am not for 1 minute suggesting that the oils cannot perform to long life specification, but what I am definitely suggesting is that the environmental issues, that's the type of conditions the vehicle is used under, short mileage, stop start, the type of driving, and once again not blaming the way the vehicle's being driven, all have a bearing on the amount of acid and carbon deposits the oil will absorb, if you like. In our view, fixed mileage servicing with a high quality, low SAPS oil of the correct viscosity is an absolute must. These products are excellent in themselves, but the result of these products obviously will be enhanced in combination with other quality products. I'm thinking in terms of filtration. OE quality filtration is an absolute must. The amount of media material that filters out the particulates, etc., is absolutely vital. Just whilst I'm filling this, this is a safety pressure relief valve. So if you want to relieve pressure, you can open that. Any residual pressure will be removed. Ensure that's closed before connecting your airline. And simply screw the top off and carefully introduce. In fact, what I will do is I'm going to lift that down to make life easier whilst I pour all of this product into the container. But to continue the discussion about the quality of filtration and lubricants is an absolute must. We as specialist automotive engineers are experiencing a lot of what we would consider premature failure, not just of DPFs, that is certainly a big issue, turbo systems, intake runners, knee jar valves, which I'm sure all of you have experienced. You have to ask the question, why? And in one word, 2 words, it's called incomplete combustion. And what we're aiming at, of course, is to try and achieve as near complete combustion as possible. One thing to bear in mind is that the diesel engine uses a long chain carbon fuel, which effectively does not burn too freely when compared with petroleum. So the more we can improve that situation with servicing, preventative measures such as what we're doing now, recovery measures of course, which this falls into that category, the better and more economic that engine will be to use. So as you can see, all the product has gone into that container. Ensure the stopper, there is a rubber seal, doesn't need to be too tight. Firm, ensure the safety relief valve is closed. Hang up, we're now waiting for connection. The regulator will then set the pressure at 6 bar, about 90 psi. Ensure that valve is off at 90 degrees to the valve. Ensure that valve is off initially until we've connected the injector device. Because of the environment concerned, this vehicle is going to be run outside with this product going through it. But that essentially is the application of the product. I've connected the timing device, the injector driver, to the battery, and you can see now the green light is on. In fact, I'll switch it to the neutral position. That triggers the delivery device inside, allowing fluid from this container under 6 bar of pressure when I open that tap to be delivered through the injector nozzle into the intake system. We're going to take off this part of the ducting. We're going to remove the main air induction hose, which is just to the underside off camera, immediately adjacent to the throttle body intake, and then that is then going to be injected into the engine whilst the engine is running on its normal fuel. What I'd like to do now is add the 244, which is the fuel additive, and I think whilst we're doing this, I'd like to add perhaps a few more interesting facts that may be helpful when considering the care and maintenance of diesel systems. The fuel additive, of course, will aid the cleaning process. Bear in mind that filtration now on modern diesel systems, this is Bosch EDC 17, latest generation, the filtration is down to 2 microns. Now, to give that some scale, the average human hair is 40 microns thickness. So that's 2 millionths of a millimetre. Once again, I'm going to make the point and the comment that filtration, fuel filtration, now of course not oil, we've discussed oil, fuel filtration is equally as important, and once again my advice is quite clear on this matter. Nothing short of OE specification filtration will do. It's an extremely expensive mistake if you get the ingestion of harmful deposits, metallic or otherwise, in the fuel system. The 244 will help the process of cleansing. It simply goes into the tank. That is now added, and nothing else is now to be done other than simply drive the vehicle. We've now arrived at the conclusive dyno run for the Hyundai Santa Fe. Just a brief overview to recount what's actually been done to the vehicle, as much of this has been done off camera due to the time lapse involved. We began by adding the 109 additive into the oil, the purpose of which was to remove any carbon-based deposits around the internal mechanical components of the engine, especially the piston rings. So we're anticipating an improvement in compression ratio with that product. We've conducted a intake system cleaner flush. That was the device which injects the cleaning agent into the intake manifold under 6 bar of pressure. Now I'd like to add an interesting point on that particular product. Some of the carbon-based deposits in the intake system are by nature soft. They will absorb some of this agent, this cleaning intake system cleaner agent, into that deposit. And what we're saying is that the effects of that treatment are ongoing, that the removal of those carbon deposits will take place over a period of many hundreds, maybe thousands of miles once that product's been applied. So that product has been done. We've changed the oil and the oil filter, and of course we've added the 244 to the fuel, so it's had a whole gambit of additive products. This is the final dyno run now to see what the difference in performance is pre-base run and with all of those products additives. So I think without further ado, let's run the dyno and let's see what happens. Welcome back to the final analysis. We've just conducted the final dyno run. We did in effect two power runs this morning and 2 power runs this afternoon. The net result is quite encouraging because 2 things have become fairly apparent. That there's both an improvement in torque. Now let me first explain that the red trace was the better of the 2 runs this morning, and the gold trace is the better of the 2 runs this afternoon. We've allowed for things like heat soak, we've allowed for things like variation in turbo spool up, which can vary from one run to another. But essentially, the big improvements in the effects of these products are between 3,000 around 4,250 RPM. Big improvement in torque and brake horsepower. Interestingly, the power output has increased at a lower engine RPM speed. So in bread and butter terms, that will produce better fuel consumption, better torque, better pulling, the need not for changing gear quite as much. But as you can see, even with, you can call it chemical engineering if you like, there's been no physical change to the engine. By treating the engine in the way that we have, it has improved the power, and this is for real. This is real world. It's been done on a dyno. I very much appreciate the expertise of Andrew and his business here in West Thornton for spending all this time with us today. It's been quite a long day and a very interesting day for all of us, and to be honest, we weren't sure what the outcome would be. I think the outcome proves the product works, that's for sure. I've never seen this done before. We didn't know. We've had excellent feedback from customers. Now with confidence we can say we've done a dyno run, and with the experience we've gained today, it's been well worthwhile. So I think the conclusion is that the product works, the effects are real. I hope you found it interesting technically as well as the net result at the end.